Hi, I'm Matt Turck from FirstMark. For this first episode of 2025, we are starting with a bang with an awesome conversation with Chip Huyen. Now, Chip is a well-known writer and computer scientist who has taught AI at Stanford, worked as an AI engineer at places like NVIDIA, Netflix, and Snorkel, and has become a bit of a superstar in the AI community through her influential writing. In today's episode, we discuss a brand new book titled AI Engineering, an impressive guide about how to build production AI applications on top of foundation models. This is a very meaty and educational conversation where we covered a lot of ground, including what is different about AI engineering.
Nowadays, anyone who wants to leverage AI to build applications can just leverage one of those amazing available models to do so.
How to evaluate AI systems.
As a more intelligent AI becomes, the harder it is to evaluate it. A lot of the failures are silent.
Why prompt engineering is underrated.
People don't take prompt engineering seriously because they think there's not much engineering to it. Anyone can do it, but not many people can do so effectively.
Why RAG is here to stay. Why planning for AI agents is so hard, and so much more. There's tons to learn in this episode, both for technical and non-technical folks, so please sit back and enjoy this fantastic chat with Chip. Chip, welcome.
Hey Matt, it's great seeing you again. Big fan of the work. Love the jokes on Twitter. So it's really nice catching up again after following you for so long.
Appreciate it. So today we are going to talk about your brand new book published by O'Reilly, which is just coming out, entitled AI Engineering, Building AI Applications with Foundation Models. Which I must say is incredible work. So I spent a good portion of last weekend reading it, and I thought it was amazing. Absolutely a must-read for anyone that's serious about the AI field. And in particular, what I've found really interesting is that there's plenty for technical folks. There's math, there's in the weeds kind of details. But equally, I've found it very approachable for non-technical people, which is very hard to do. So again, really enjoy it. Congrats. And to jump to the punchline, people should absolutely get the book. And what we're going to try today is give people a little bit of a flavor for what's in it. So obviously, we're not going to cover everything because it's 500 pages of goodness. But hopefully that will give people some kind of overview. Does that sound good?
Yeah, thank you so much. And everyone listen to Matt. He knows what he's talking about. So appreciate it.
All right. So let's jump into it. So at the beginning of the book, you make the point that while AI adoption seems new, it's built upon techniques that have been around for a while, like language models, some of which came in the 1950s, and then retrieval techniques. But at the same time, it feels like a new field. So what is new about AI engineering, and how is that different from more traditional machine learning and MLOps techniques?
Yeah, I think that's a great question. And I get asked that question a lot. It was okay, what is AI engineering? Is it another marketing term? How is it different from traditional ML engineering? So there's a lot of overlap between these two roles. And I think a lot of companies, even people with the same title, can have very different functionality. So I think any definition is a little bit fuzzy and really depends on where you work and what you're working on. But in general, I think of machine learning engineering is when you have to build the models yourself. Before the availability of large language models or foundation models that anyone can access, if you wanted to build ML applications, you could need to build the models yourself, and only a few organizations could do that. But nowadays, anyone who wants to leverage AI to build applications can just leverage one of those amazing available models to do so, and it just makes it so much more accessible. And another thing is that before, I had thought that a small improvement of AI capabilities could lead to a small increase in the number of available applications. So we know for a long time, we have known that if we put more data and more compute, we would get better models, right? But still, when ChatGPT came out, we were shocked. I was in a group chat with a bunch of my friends, and we was really, really shocked. And the reason is that we were shocked by just a small improvement in capabilities can lead to so many applications. So at the same time, we have so many new ideas, and at the same time, we're like it's so easy for you to build applications. It's just like the energy, the community is just like growing like exponentially. It's like really, really, really exciting time. So there are like a lot of new things with that. One is that like evaluation is become so much harder. So before with a lot of traditional ML, we have like okay, if we do like spam detections, right? Like we know that the output should be spam or not spam. So if the model's output is not spam and the real email is a spam, then we know that like the prediction is incorrect. But now like, if you ask a model to say, hey, summarize a book, right? And the summary looks like quite reason like coherent. You don't know if it's a good summary or not. You might actually have to read the book to find out yourself. And also like as a more intelligent AI becomes, like the harder it is to evaluate it. So for example, like for math problems. So I think that most of us can tell if the solution to your first grade of math questions is wrong or not. At least I hope. At least I hope that most of us, and with a lot of complaint about education going on, I'm not sure if that's still the case. But yeah, but like for the PhD level math questions, I think it's very few of us can actually tell. So it's just like now AI can just like have like questions that's like not very correct. Like a lot of the failures is silent. So it's like really really hard to evaluate. And another aspect is a question of like a product. So I think like before, right? Like you knew what you were going to build because like you're part of the organization. So once you leverage data and ML to like speed up whatsoever, make more money. So you knew what you were going to build. But nowadays it's like you can start, you can build anything. So usually start with like a product, right? Like you start with an idea, a demo, and then if it goes really well, then you start like investing in data to make it better. And then if it's cooked really well, it's like, okay, now we are paying too much money for like OpenAI and Anthropic or Google. So now we need to build our own model. Like, and so now we invest into the model. So like the process now is like, yeah, like product to data.
Is that the reversed process compared to traditional machine learning, where you would start with the data and then build the model and then build the product?
Yes. So I think the process is like kind of reversed, and also leads to people like a lot like closer, like product people and ML people and data people like are a lot closer. Like in some team, you might have like to be like the same persons. So like it requires engineers to have a much better product sense. So a complaint I often hear is just like, okay, the technical aspect of this application is really easy, but understanding what users want is like really really hard.
So does it mean that a traditional machine learning engineer and an AI engineer may be two different people, two different professions? What is the overlap between both?
So I see it's like very differently at different companies. So for example, like say a lot of companies, they already have an ML team. So when they started adopting AI foundational models, generative AI, then they task this team to like, okay, go and explore and build stuff, right? So I think it's like this overlap. But I also see a lot of teams like hiring separately for like generative AI. So it really depends from organization to organizations. One thing I do notice is that it's not a question of or. Like, do I use like a classifier or generative AI? Right? It's more of like, and it's a vast majority of generative AI systems I've seen. Like you have like traditional or like analytical ML components with generative AI. So let's say that, for example, of a customer support chatbot. So you have a request from customers, and then you want to respond to that. Like, so maybe like you have like you employ a bunch of models. Maybe like a really difficult request, you want to send it to like the strongest and most expensive model. But like the easier request is send it to like maybe a locally hosted like open source model. But some requests are like sensitive, like a billing complaint. So you might want to route to a human operator, right? Or so like when you get a request, you need like an intent classifier to say like, hey, what is this request about? So and then you can route that accordingly. So that intent classification model can be a traditional like ML like classifier. Or another things is that like when the model maybe like a fancy model generate a response, what if it contains some like personal like PII information? So you might have like a detector like, hey, does this contain PII or not? So that can also be like a traditional machine learning model. So I see that used together like in a lot of cases. So I do think that there are a lot of overlap. And I do think it's like people can like, if you traditional ML engineering background, you can also like just learn more about foundation models and how to work with foundation model to become AI engineers. And so see that people coming into AI engineering with absolutely no ML background, because you can just like do an API call and you don't need like a lot of people can't really explain gradient descent. And not necessarily, I think it's a big debate on whether people need to know that to become good AI engineer or not. But I definitely see a lot of people building very cool applications without traditional ML background.
And just to play it back, what you're seeing in the field is hybrid systems that combine foundation models and generative AI systems and traditional machine learning models. I'm just repeating this because that seems something that just about every practitioner in the field sees and agrees with. However, in the general public, there seems to be a narrative that generative AI is completely ripping and replacing all forms of AI that came before it. But just to confirm, that's not what you're seeing at all.
I would love to see people unseating XGBoost. I think it's like an uphill battle. Yeah.
So the generative AI stack, that's the foundation of generative AI. What are the different components that people should know?
So so when I look into like building applications, I would think about like maybe a developmental process, and maybe the stack should be like evolved to like address like your needs, right? So when you start with applications, maybe you start building like thinking about like maybe you start with like a testing out the models. So you might want to like do some prompt engineering, since you know how far you can get with prompt engineering. Maybe you need to curate some evaluation metrics. You definitely need to evaluate like to design some evaluation metrics. So I think of it as like the application development layer, right? Like with prompt engineering, maybe work with like how to like enforce like structure output, security guardrails, maybe like with definitely with evaluations. And then like after you do it, so we can application layer. And then we go and then we max out that performance there, and then we're gonna, hey, maybe we need to like change the model, right? Like maybe we need to like fine tune the model. We need to make the model smaller, make it faster, like inference optimizations. So like that layer, when you actually make some changes to the models itself, so it connects like the model development or like fine tuning layer. And then like after that, I think you go into like infrastructure, like you deploy the applications, and now you have you need to scale up, right? You have to think about like compute, you have to think about where's the data is stored. So like that's like infrastructure, or like it's like started building as a platform, so that can make the deployment and iterations like faster and more reliable. So basically there are like three, I think of them as like three layers, like application layer, application development layer on top, and then model development layer, encompassing both like developing a model from scratch and like fine tuning or making changes to the models. Ideally, you don't have to build a model from scratch. And then at the bottom is like infrastructure, just like powering everything.
So scale, which you mentioned a second ago, seems to be, or is very much, I should say, at the heart of the entire generative AI approach. What is it that's so special about language models that make them so reactive to this scaling approach that led to the ChatGPT moment?
Yeah, that is like a really good question, and I feel like that's a question that I think today a lot of people take for granted. But it was not obvious before that like language could be the way to scale intelligence, right? I think like in the early day, at least like when I got into AI, it was like in the like 2014, people were still debating like what's the big computer visions or like language or reinforcement learning, because computer vision was like, oh, because like we developed ways to see way before we started developing languages. So maybe like seeing is a way we scale intelligence, right? So it was not really obvious. And I remember back in like 2017, I was at this OpenAI party, and somebody told me, it's like, hey, guess what? We just like keep on throwing text, and now this model is like pretty smart. So it was like people just like start like realize it's like, okay, we just keep on getting more text, then we get like much better models. And why language modelings, right? Because they want to like other text models like machine translations. I was actually very bullish on a machine translation. I thought it was a really difficult task back in 2014, 2015. And now it was like pretty much like people are saying that machine translation is like pretty much solved for like major languages. I mean, we still have the long tail of like less lower resource languages. But yeah, so the thing about language modeling is that it's a very simple task and it's like really elegant. So the idea is that you can predict, like the idea is like try to build, like to get enough statistical information about the language so that you can predict like what comes next in a sequence, right? The idea is like if you say like, hey, my favorite color is, then you should be able to predict that blue is going to be more likely than say car.
And that's what you called auto-regressive models. Is that right?
Yeah. So I think like that auto-regressive is definitely one type of language models. So I think like the idea like all language models is like to encode like statistical informations. And that concept actually not new. Like I think like people employ that to like decode, like to break code during World War II, right? Like people like using that like for games, and it's very very interesting. So auto-regressive, like you mentioned, is like to predict what comes next, whereas like the math one is like you can have a context from both before and after and predict what is in the middle. And both kind of language modeling tasks are actually can the data is like abundant. Like if you have some tasks like machine translations, you would have to like curate like here is the original sentence and here's the translations, and it can be quite painful to curate that. But for language modeling, because you can just have any natural text like online, like it's like so much of it online, you can just use it. And also like not just like a natural text, you can use like programming languages, like you can use like code bases. And I think like that is just like that's the nature of it, is like you don't need to curate like labels like reference data, so that you can use to train models that make language modeling like so much easier to scale than other types of tasks.
And maybe to put terms around it, can you quickly define for us supervised versus unsupervised versus self-supervised?
Yeah. So the approach of like you having like purposefully like curating the labels for the model to train from, like fraud detections, right? For example, you have to just train it down, maybe like here's a transactions, here's a label, and the label can be like fraud or not fraud, or like spam detection. Then the data is an email, and then the label is like spam or not spam. So you have to curating, like creating those labels, the process of manual curating, like, and you teach the model like to like learn from those labels. So that process is like supervision. So the other spectrum is like unsupervised. It's like you don't need to tell the model like the labels, and the model figure it out. First, for clustering. So if you throw in a lot of like articles to the model and say, hey, try to like groups this into like 5 groups. So you don't need to tell the models like, okay, this group is technology or something like that, right? Like you just like the model can do it. Like a lot of clustering algorithms are like unsupervised. Language modeling is somewhere in the middle. It's like it's self-supervised, and the reason is that it's still like learned from some labels. Like first of all, like the next word in a sequence is a label that it will need to learn to predict, but these labels come like naturally. Like you don't need to manually curate it. Like you just like get any text and you can like generate a bunch of training samples. So yes, so that's the self supervision.
And still on the topic of scale, why does it matter how big a model is in terms of, millions or billions of parameters? What difference does it make?
That is very interesting question as well. I love how you're asking like these very deep philosophical questions, and I feel like I really need a whiteboard to be able to explain all of this. So people, if you don't understand me, trust me, my writing is better than my speaking. So like, why does it matter? Is as the model should have a lot of parameters. So parameters like the numbers of parameters usually like approximates like the model's learning capabilities. So it's just more like with more. So you can think of like having more parameters, assuming more ways for the model to like learn information. So you can think I'm trying really hard not to use the term like neurons, the brain having more synapses. You can learn more. It's just like it's not that equivalent. But yeah, so basically you can think of like the number of parameters is more learning capabilities of the learning capacity of the model. So the more parameters allowing the model to learn more. So that's actually a very interesting question is that like why do larger models need more data to learn? Because the idea is that if the model has more capacity to learn, should it need less data to learn? Does that make sense? Like if someone is
Yep.
smarter, right, it should
Learn
need to
faster
learn
from
less.
less data.
Yeah. So I think that's the idea is just like because it has more capacity to learn, it could be a waste of this capacity if you don't teach it more. So like yes, you can train a large model using very very small data set, but that could be a waste of compute and the waste of that model potential. You might achieve like much better performance just like training a smaller model with a small data set. So yes, so like larger models allows the model to learn more and they give it more data, allow it to like maximize its learning potential and that be able to do much more powerful tasks.
Could you go into some other approaches to make a smaller model very performant? In particular, I'm thinking of a mixture of experts. Can you maybe define for us what that is and what the general goal is?
So I do think it's like the goal of making the model smaller, like making smaller model better is actually like a very important goal, and it's just what like everyone is trying to do. So one thing I want to point out that like so what is considered small or large is actually very time dependent. Like what is considered like large 10 years ago is considered tiny today. So I feel like what is considered like large today might be considered like small in the future. And we have seen time and time again, for example, like the same llama model families, right? Like the llama 3 model, the smaller model in llama 3 families probably perform better than the model in the first llama generations. So like it's like over time we actually learn more like how to make model perform better with like being smaller size. So like how to make models smaller model better. So I think like a lot of way like we can use better data. Like we have seen just like higher quality data can actually lead to like better performance. People like show that a lot. Better training techniques, like new alignment techniques. Also like maybe like different architecture that you mentioned, like mixture of experts. So mixture of experts is an interesting term because it's like it has been reused for different meanings over the years, right? Like before we have the expert systems, and a mixture of expert means different things from like what people call like the mixture of expert models nowadays. So the idea is that like for example like you can have like not quite human expert. You can have like different maybe like okay, maybe you can divide the model into different heads, right? And each head specialize into some things, and then like these heads like instead of like training like experts like entirely from the beginning, like which like have a lot of parameters, you make this expert share some parameters, and then it has some kind of route in the middle to determine like which head is the most suitable. So its ideas is like these different components can share parameters to make it more efficient, like parameter efficient, where you can doing like multiple kind of like complicated task. Yeah, so I think there's a definitely like one pretty interesting approach. But also like there are more. It's harder to train. So usually I don't see people saying, "Hey, I'm gonna make a mixture of expert model today." Like people don't wake up and like want to do that. You know, it's pretty hard. I think like for a lot of people, they could probably use something like, "Hey, I maybe like do like quantizations," which is like very universally, very working really well for a lot of tasks across model. Another people might try to do is just like doing like a distillations. So like you have like a bigger model teaching a smaller model, like so that the smaller model like learn to mimic the behavior of the bigger model. So yeah, so I think that's a very 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 fascinating question that you ask. And I might write another book about it.
You heard it here first. Okay. So speaking of training, walk us through, in a nutshell, the different phases of how you train those models. And so there's a pre-training, but like in particular, I was very interested reading the book about the post-training phase, which is there's a lot more to it than I had read about previously. So yeah, maybe walk us through the steps, please.
Yeah, I really kind before I go into it, is when I say I kind of hate the terms. Like it's like the pre-training and post-training. It's just like a little bit like confusing, and I feel like the AI research community is really great in many things, but like naming is probably not one of those. So I think it's like the process of training or like creating a model like ChatGPT have like has a pre-training phase is when you train a model on the language modeling task. So during this phase, the model gets really, really good at predicting what comes next, right? So it's like completion. So it's like you just say it's like to be or not. It will complete with like to be. So it's very good at that. However, people realize it's like okay, completion is good, but then it's not very useful in day to day, because let's say it's like I asked it's like how to make pizza. It might answer with for six because it's trying to complete the sentence like how to make pizza for six, right? So like a lot of time it's like completion is not always as like solving a task. So like that's where the post-training come in. It's like you teach this model who has like a lot of statistical informations about like all the knowledge of the world. Now how to get it to respond in a way that is helpful to humans who are interacting with it. So in this phase, like it's called like post training. So you can do it like people have like multiple techniques, but like and what I'm going to say here is not always like the only way to do it, but definitely a common way to do it. So like in the first phase of like post training, maybe like it's called like self supervision. You can do self supervisions. So you can curate like a bunch of like here's the instruction from humans, and here's how to complete that instructions. So for if the instruction is like write me an essay about how wonderful my talk is, right? You can write like an essay. So here's that's the response, like instruction. So you train the model to like mimics that humans' behaviors of like here's the instructions and here's how to respond. Another and then like another phase that's pretty common is when you actually like try to get the model to maximize the chance of it generating good response and lower the chance of it generating like bad response. So like you can use techniques like reinforcement learning, like IOHF, like reinforcement learning from human feedback, or like DPO, direct preference optimizations. So basically, there are a lot of other techniques around this like post training, and unfortunately, a lot of labs that are doing it are not quite like publishing papers about it. So a lot of works that we just need to be able to like know who to talk to, interviewing the right people, and then trying to get them to say like off the record. But yes, that
Oh,
space
interesting. Is that because
yeah.
that's a big part of the secret sauce that those commercial proprietary sort of labs want to preserve?
Yeah, so if I think about it, like what makes a cloud model so different from ChatGPT and like Gemini. So like the pre-training phase for a lot of companies, they have the same data because everyone is scraping the internet, right? Like everyone is get basically the same data. So the language modeling task, like everyone is optimizing for like entropy, like perplexity, right? So what makes like these models really different during the post-training phase? So like they curate data differently, they like have different ways of like collecting like human preference and like training for that. So I do think that post training is what makes this like really big lab models are like different.
You mentioned a term called sampling in the book that is very interesting, and you mentioned very important in terms of understanding how those models behave. Can you maybe define that for us?
Sampling is really fascinating. I think it's actually the writing section sampling is like one of those that bring me the most joy because I really like it. So and I feel like the topic is really underrated. So sampling is a process of a language model picks a possible, like pick one output out of so many possible outputs, right? So we talk about the language model like encodes the statistical information about language. So let's say I say this like the answer to this question is 70% yes, 30% maybe, and 20% no, and then 10% maybe, right? So the model is like models, I look at all these possibilities like what should I pick next? So maybe 70% of the time it's gonna pick yes, and like 20% is a big no, and then 10% is a big maybe. So that is a sampling process. And the language model, right? You don't just, it doesn't just sample like each response is not just one token or like one word, right? It has to respond like it sample like over and over and over again. So sampling refers to like different techniques, so that you different strategies to like nudge the model to pick the output that is more valuable to you. So let's say just like for example, like one thing people do use like temperature. So you can nudge the model to like pick more frequent tokens. For example, like for every, like in the simplest way, right? You nudge the model to pick the most frequent, most likely token. So in that way, you would notice that the models become quite boring, because it wouldn't always pick like what is the most frequently spoken, like the most common phrases. First of all, you can ask like, hey, what's your favorite color? People like, my favorite color is blue, or like my favorite color is red. Like it's big, very simple. It would be pretty unlikely to generate something like, my favorite color is the color of blue sky reflected in the still water, whatever, like something creative. So if you want something more creative, you would want to nudge the model to sample something that is like more less frequent. But now the tricky part, because if you want the model to pick something like really rare, it might become incoherent as well. So basically, sampling refers to this whole families of like different strategies to like nudge the model to like generate the responses like equivalent, like most suitable for the task. And I do think this like is fascinating and it's interesting and useful, because it's a nice, it's a cheap way to improve the model, like the application's performance, without having to retrain the model. It is also really useful for debugging the applications. For example, you can see like maybe the model like output like reasonable, but you can look at like the probability. For example, like if you ask this a bunch of like yes or no questions, and the correct answer is yes, but the probability for the yes is like really low, then maybe the model is not that confident, right? So you want to look into that. So yes, sampling is very cool.
All right, so let's go into the general topic of evaluation, which you mentioned up front is one of the key things in designing those AI systems. You have a sentence which I really liked in the book that summarizes it all. That says, as teams rush to adopt AI, many quickly realize that the biggest hurdle to bringing AI applications to reality is evaluation. For some applications, figure out evaluation can take up the majority of the development effort. So you mentioned some of the specific challenges of why is it so hard to evaluate. How does one think about evaluating those models?
Yeah, evaluation is hard. So I think like I realize this term like what I call evaluation driven development. So this comes from engineering, the concept of like test driven development. So the idea is that like you develop applications that you can evaluate, right? Even though it's like I think I see a lot of people are excited about like the latest marketing buzzwords, I think it's like one thing I've realized from working with a lot of tech executives is that they're actually really smart. And I think like a lot, like surprise, he becomes the SVP of these giant corporations because they're pretty smart. But yeah, so I think like a lot of business decisions are still made based on return on investment. So that's like it's really hard for people to like say like double down on something if they can't say just like, hey, this is making like real money for us. So it's not a surprise, it's not a coincidence that some of the most popular AI applications today are those that you can evaluate the output like pretty clearly. So for example, like recommender systems, like everyone has a recommender system nowadays, and it's because like with recommender system, you can tell like how much money is bringing in by like whether it's increasing, like say like click-through rate or like purchase through rate, right? So like we say, okay, after we launch the perimeter system, now suddenly our purchase through rate like increased by like 2 or 3%. And like of course like we have to like minus thinking about all the confounding factors like campaigns, but maybe I'm talking it very simplistically. Or like for fraud detections. It's very common nowadays because you can tell very clearly that like like how many fraudulent transactions of like you were able to like flag and like stopped. And like for generative AI, like one of the most common generative AI use cases today is coding. Okay, so there are many reasons why coding is popular. And I said like one of the reasons is that it's a lot easier to evaluate coding than like other, because like here's generated code, right? You can evaluate like does it compile, right? And like does it generate the expected output? And testing code is not new in software engineering. Like people have been doing like all different kind of tests, like unit tests, integration tests. So like so people know how to evaluate like generated code. So yeah, so like coding is like actually very important. So I do think it's like if like no matter how exciting a use case seems to be, if enterprise like don't see a way to evaluate its outcome, it's very hard to like nudge them to like adopt it. So I do think it's like evaluation is the biggest bottleneck for like AI adoptions, because unless like if we can like develop a more reliable way to evaluate that application is not going to get adopted. Like or maybe it can. Maybe we need some billionaire to just like steamroll fund it. But yeah, it's challenging.
So what are the key concepts around evaluation? So you mentioned a couple of those terms like entropy and perplexity. What are the criteria? What are the methods? What should people know about?
Yeah. So you mentioned like entropy and perplexity. So those are really fascinating concept, and they actually guide the development of language models. But because most people today are not going to build a language model from scratch, you might probably do it for fun, but not going to be at a scale where you can compete with OpenAI. So I think like entropy and perplexity is useful to know, but probably not what you are going to use day to day to evaluate your applications. So I can talk about like entropy and perplexity. I think they're like really cool concept. So on things I want to mention about that is just like we want like entropy to be like lower. So like to make things like basically more predictable. So for example, like if the model is getting really good at predicting like the next token, so that means that's like now the journey that becomes like that language become like more predictable to the model, right? So the entropy is gonna be low. And over time, people find out it's like, hey, if I could just decrease entropy, somehow users are happier. Like all the user using the applications are become happy. And then the question is like, how far can I go? Like how low can the entropy go, right? Because like after like it can't go to like zero. I think people have been talking about like, is there like a lower bound of like how far can you go with entropy? Like how much room do we have left to push the performance of these language models? And there's this concept like the irreducible loss. So like language has some certain aspect of like unpredictability, right? There's just no, I don't think we'd ever reach the point like we can predict the next token like perfectly, because there's always some variations in the way we speak, right? So I do think that's like there is this like a reducible loss. And I'm not sure you saw a bunch of people talking recently about like the end of like pre-training. And I think like there are multiple reasons. Could be like once like we don't have data for pre-training. The second is just like the perplexity, like the entropy of this language are pretty low, and it might be like very close to what could be like theoretically possible. So I think when Klaus Shannon introduced the concept of like entropy, he did some pretty fun exercise. Like he asked a question like, what is the entropy of the English language? So like that could be like the lower bound. Like, but like because he did that back in 1950s, he did that based on like a very short sequence of like maybe 10 character, like 10 10 words. And the interesting thing about entropy is that like the more preceding, the longer the preceding sequence, like the longer the context, the easier it is to predict the next token, right? Like usually if I have like, if you just tell me one word, it's be very hard for me to predict the next word. If you just say like I, right? It was like, I'm going to go with like, I am, I want, I love, I hate, right? But if say like, if you give me like a sequence of like pretty long, for example, like, you want to say like today I would like to welcome my, I can predict guest, the next words will be guest, right? So the longer the sequence, the easy, more predictable the next token is, and the lower the entropy. So Claude Shannon did in 1950s like the exercise with very short preceding sequence. So I would really love to see like if somebody like today do that, like study that, but like for really, really, really long sequences.
And so, if a concept like entropy is not something that people that build those AI systems in real life, so not the model developers, but like the AI engineers who deploy AI systems, if that's not the kind of topic that they need to worry about or use in their evaluations, what should they use? What are some of the key techniques and key concepts to evaluate AI systems in production in real life?
Yeah, so I think like as a lot of corporations go is to make money, I think the ultimate metric is whether it's making you money or not. But I feel like that could be like too broad, right? Because many things can like cause whether company make money or not making money. So I think like for applications, it's really really important to understand the use cases well so they can design like the set of metrics, and then you can work backward from that and map it to like the model metrics that you care about. So let's say like for example like you do a text to SQL model. I feel like back in like 2023, I got like every week I would got some engineers is like, hey, check out my new text to SQL model.
Yep, pretty
And I
much.
was like, wow. People would do anything to avoid writing SQL queries. Yeah, so let's say it's like you're like data companies, right? And I thought usually interact with your data using SQL. And it was like, oh my God, writing SQL is so painful. So let's help people write like natural language to write that. So let's say you have a text to SQL model. Then how do you know that the model is good? So maybe like you can start thinking from like from the user from like user perspective, like from your perspective, why do you want to develop this model? First, like maybe you want to like improve users productivity. So like maybe you can use a metrics of like time to like speed to completions. So maybe before, like without the tool, users would take like on average maybe like 3 minutes to write a SQL query, but now with a tool it takes only 1 minute, right? So it's like having this kind of like metrics would be very useful. Or like another like customer support, you can also like similar, for example, like before you can respond to, I don't know, users have to take like 2 hours for the agent to get to the users, but now it can respond instantly. But that's not always the case, because by default, if it responds automatically, it will always like be fast, right? So need to think more about the case of like, are users like happy, and I or so that is like the ultimate case evaluation metrics. I do think it's like it's really dependent on the use case and your companies and what you care about. But then you look backward from that. It's like, okay, now I don't want to deploy the application yet, right? Because I want some validations offline to be able to like know whether this is good or not. So you need to like evaluate. Like, you can create sort of evaluations like systems to evaluate that.
Still on the topic of evaluation, an interesting tidbit you talk about is the concept of AI as a judge. So somebody or something needs to evaluate the system. It could be a human, it could be AI. What are your thoughts on the pros and cons of AI as a judge?
Yeah, I do think it's like AI as a judge is a very promising approach. So I do think that I think when when ChatGPT first came out, AI as a judge was just like AI is not reliable enough as to be entrusted with a crucial task. But I think that nowadays you talk to like teams, I think like most teams have like some variations of like AI as a judge going on. So AI as a judge is pretty interesting. The idea is that like you have a AI evaluating the outputs of like other AI, and it's especially useful in productions. So the idea is that like let's say like the model, you use a model to generate a response. And a lot of people were like, oh my god, what if the response is like not safe? What if the response is like crazy? What if it's like saying something like get me sue? So maybe you can have another model like to double check this one and give a score and send back. So AI as a judge is like pretty, it has been like able to show to work like very pretty strongly correlated with like human judgment. And the tricky thing about AI as a judge is that AI as a judge is not as, how to say, exact as it's not subjective as other metrics like F1 score or like so what that means is that like when somebody say F1 score, you know that, you know what that means, you know how it's defined, right? And if I run a calculation F1 score again, even writing using my own F1 score code, I will get the same F1 score ideally. But for as a judge, it really depends on what the judge is, like which model is a judge model and what the prompt is. And one thing I noticed is that like for a lot of those judges can like evolve over time. So with evaluations, like ideally you want the evaluation method to be stationary so that it can benchmark your application over time. So let's say that yesterday, so evaluation metric was like maybe 90%, and today it's like 92%. And you know that, okay, so my application is getting better. But with AI as a judge, what could happen is that the judge itself change. So that like it's not comparable between 90% and 92%. And I once talked with a team who's like a pretty big company. It's a pretty common scenario with a lot of companies. It's like especially when they're bigger, is that they might have a team that like developed AI judges. Like they maybe like write a prompt for AI judge. Maybe the judge could be like a faithfulness score or like a relevance score, and a downstream team to like user judge. So like this one engineer came to me and said like, hey, we have this faithfulness score of like 90%. And I was like, okay, that's great. So what is the prompt that you use for the judge? And he was like, I actually don't know. I'm not, and I just use it off the shelf. So I do think it's really, really tricky when you don't when you don't have control over the judge.
So we were just talking about prompts. So let's turn to prompt engineering. And you wrote that prompt engineering's ease of use can mislead people into thinking that there's not much to it. So maybe a quick reminder on what prompt engineering is in the first place, and how should AI engineers think about it or approach it?
Yeah, so I think like when I mentioned that I have like a section of prompt engineering, I did have few people that rolled their eyes like, oh my god, prompt engineering, blah blah. So a lot of things is like there's not like a lot of people don't take prompt engineering seriously because I think there's like not much engineering to it. So maybe like it go back to like maybe what is a prompt? So the prompt is like how you communicate with a model. So I think of it as like writing prompt is just like writing. I mean, does it make sense? So like you can think of like writing prompt as like like human to computer communications, and just as like human to human communications, like anyone can do it, but not many people can do so effectively. So like because like anyone can say okay, I can just write this prompt. So people saying okay, if anyone can do that, there's it's like it's so easy, like there's nothing about it. And especially it's quite misleading in the early on when we had a lot of like hackiness when it comes to writing prompt. For example, say like some I think one of the funniest tip I saw on prompt engineering is just like, if you tell the models like answer correctly, I wouldn't give you $200. Right? It's just like it's just
Bribing the
like
model.
yes, bribing the model, or like so people was like okay, you just like do like stuff like that and get more to do things. But even though there's a lot of like how to say tricking, So a lot of like tricking the tech the instructions to get what you want. I do think that it can be very systematic. You should need to make it very systematic. So if you consider like each prompt is experiment, it should be watching like versions of prompt. It should be able to systematically track your progress with different prompts. You don't want to just like like use a prompt and somebody makes random changes, have no idea what's going on, and the downstream people like just like have no idea like what change of applications and why the output is different. So I do think that's like yeah, like prompting is very easy to get started, but like to do so effectively does require a lot of practices and a lot of like discipline to do so like systematically.
What is in context learning when it comes to prompt engineering?
That is very. By the way, do you think like most of the audience would know like what in context learning is?
No, but they're gonna learn thanks to you.
Okay, so in context learning is actually like pretty. Nowadays, it's one of those things people take for granted. But it was not. It was a pretty novel idea when it came out. So in context learning, so now like when you talk to a model, right? You give instructions, you give some information. So some people call like a lot of people call it the entire thing that you input into the model to get the model to do what you want is the context, right? So the context is actually very confusing. We're gonna go into that later. But yeah, so like you give the model a bunch of like information to get the model to do what you want. So that is a context. And if you give it some examples, like if I say, let's say if I say car, you say vehicles. If I say bananas, you say fruit. If I say house, you say building, right? And it says this is the next thing. Maybe even people like you say train, maybe you can say like you will know how to output vehicle, for example, right? So I think like so when you put the examples into the model is able to learn from these examples and output the correct category or like the correct output. And that idea was novel when it came out because before, if you want the model to be able to predict, like to get the correct output, we had to change to train the model, especially for the task. Like before we want to like say like oh like predict the category of this object, right? We need to like curate the training data of like name to like category, had to train the model on it. But now with language model, it's just like you can just like independent, like you don't need to train the model from scratch. You just need to input some examples in that, and then it to like exhibit the behavior that you want. So that is in context learning, like the model learn from the context given to it. So I have this whole term of like few shot learning, zero shot learning. Zero shot learning is like when it can like do what you want without any examples at all. For example, it can say like give me tell me whether this email is spam or not spam, and give it the email and no other examples. Then that's zero shot learning. But then you have like maybe like 5 emails, each of them with like a label of like spam or not spam, and then the email you want to classify. So now you have like 5 examples for the model to learn from, and now it's like 5 shot learning. Yeah.
So it's a really big deal, right? Because like as you said, like you don't have to go back and like retrain a whole model with like brand new data. You can extend an existing model with knowledge without any kind of like coding or training. Okay, interesting.
Yeah, it's a big deal because it makes language models so versatile and it's so useful to a lot of applications. So it's like what make a general model. Before, like if you want a model for a task, you need to train a model for the task. But now you have like a model trained like generally for language modeling, and now you can just like adapt it to any task with in context learning.
And there's a part in the prompt engineering section that I thought was particularly interesting around defensive prompt engineering, so defense around against jailbreaking, information extraction, that kind of thing. Can you talk about that and maybe what we have learned about making those AI systems resistant to those kind of attacks?
So I do think that the topic is getting increasingly important, especially as AI is being like first AI is being used for more like high stake tasks, right, and more complex tasks. And the second is like it's now AI has increasing access to like more tools, and it can make changes. So I do think that like there are so we do want AI like users to be safe, like protecting not just users but also like developers of those models that nobody gets to. I think that with it's also like when one reasons that makes a lot of people like go to like proprietary models instead of open source model, because I say if you use like a model like developed by a company, so like through the API, you kind of have some like this is companies are responsible for like putting guardrail to make sure that model behave safely. Like it doesn't say anything racist, sexist. Somebody asks this question about like praising Hitler, maybe you can say no, I'm not gonna do it, right? Like there's a lot of guardrails around this. But if you use like an open source model and you deploy yourself, you're like responsible for it yourself. So I do think just like of course open source model developers they try their best to make the models like safe as well, right? But they also have less visibilities into how the open source models are being used. So which gives them like less information for them to like make the model safe. So I do think just like defensive like prompt engineering is very important. It's like it refers to the process of like writing the prompts in a way that makes the model safe. So for example, like maybe nobody actually knows what a ChatGPT system prompt or like Claude system prompt is, but I bet that like they contain a lot of like languages just like tells the model like do not respond to this kind of request. If you ask this, say this, do not be this, do not be that, do not be that, right?
Yeah.
So when
And
you
just maybe
write your prompt,
to make sure this is like everyone understands. So there's a user prompt, but there's a concept of a system prompt, which is like the prompt behind the scenes, right? Like the prompt behind the
oh
prompt
yeah,
that tells once you as a ChatGPT user have typed in something, then there is a second layer that tells the model to do or not do certain things. Is that fair?
yes, Matt, you think you could be a great teacher? Oh yeah, no,
It was
that's a
because
good
I read your
point.
book.
Thank you. Yeah, so you do have like the user prompt and the system prompt. So the system prompt is like say I'm an application developer and I develop an app of like, hey, given a disclosures for a house, then you users can like ask questions about the disclosures, right? So as an application developer, I write a system prompt like, hey, model act like a real estate agent and given a disclosure the users will ask you, so act like professionally, be nice, be kind, be brief. And then users promise like, here's a disclosure. Tell me how big is a lot? Like how is that compare like in any noise complaints? So your system prompt is like built by like created by the system like application developer, and user prompt is like when users interact with the applications via like whatever they like language they use. So yeah, system prompt is when you need to put in all these like languages to make sure that the application acts in a way you want it to act.
All right, let's spend a couple of minutes on another very important part of AI application architecture, which is RAG. Maybe a quick reminder for folks about what RAG is. And then one specific question or topic sentence that caught my attention is when you wrote that many people think that a sufficiently long context or context window will be the end of RAG, but like you don't think so. So what do you mean? What do you mean by that?
Yeah. So I think it's like originally rack was developed to get around like shorter context, right? So I think like originally I hope she did like tweet in like 2017 or something, maybe, and she reference my book. But yes, the idea is just like for a lot of like knowledge based knowledge intensive applications or questions, and where you cannot fit the entire knowledge needed in the context, then you need to retrieve it from somewhere. For example, like if you need to rely on Wikipedia and you cannot fit the entire Wikipedia in your context. So maybe you need to find like the article most relevant to the question, retrieve it, and put in the context instead. So that's the idea of original. It was like designed to, like, to get around that issue. And then some people were like, okay, as the models get a real long context, maybe you don't need RAG anymore because you can just dump the entire enterprise database into the context and you can just retrieve it. So I do think that's like the questions of like whether long context could make RAG obsolete is similar to like will like larger with larger computer like laptop memory will make data center obsolete. So I feel like no matter how big my phone memory or my laptop memory is, I will always run out of memory. So like people when we only like having more and more informations. So it's like I think we always expand our usage to fit in whatever context length that's going to be available. And the second thing is that like just because a model, I think the second reason may be actually more important, at least for now, is that just because a model can fit in a million token context doesn't mean that it can process that million token efficiently. So I think that's like, for example, I was like, actually using Claude and ChatGPT for like some of the novel writing. I'm actually really want to write a math novel, and what I found out is that like because I when I write story, right, you need to be able to keep track of like events in the past. And I found out it's like anything that's like over like 10, if I input like, any text is like around like 10,000 tokens length, like the model would just like completely like forget, like confuse timeline. It would think that oh this character actually met that character instead. Like it is like really not efficient at all on like understanding large context. And I feel like some model developers when they have the drag guidelines. They have some guidelines. Hey, for anything that beyond these X things, maybe try to use rack. If it's shorter than that, you can dump everything into it. But really, it really depends on the use case, and I think that people like really need to test out the context efficiency for their application.
All right. So, as promised, let's close with everyone's favorite topic of the day: AI agents. So, I guess let's define the term first of all, because everyone seems to be using different definitions for the term. So, like, what is an AI agent for you?
That is, I feel like it's a trap question. You were like, okay,
It
everyone
is.
disagree on the term. Now tell me what the term is. By the way, Matt, do you invest in any agent companies?
Of course, I'm a VC. I have to. The two things I need to do as a VC is one, I need to have a podcast. Two, I need to invest in AI agents. Those are the rules.
So I think it's like I actually like a lot of the early reviewers like they have a very extreme bipolar opinions on agent. So I decided it's like okay for this case like agent is not a new term. It's not like a term that's like no one has ever heard of. It's actually like a term used in AI for a very long time. So I was like okay let's just go back to the basics and I just go like just take out some like AI textbook from the 80s and 90s and see like how people define agents. It actually makes things a lot easier. So I actually base my definition in my books based on Peter Novick's and Russell's books from the 90s. It's like it's a really good book. So basically, they define agents as anything that can perceive the environment and interact with the environment. So like it has like two components, right? Like the sensors, like to get information from the environment, and then it can perform actions in that environment. So what does it mean in the context of like AI power agent, right? So like AI power agents already can interact with the environment. For example, if you ask it like, hey, search the internet, that means it's like retrieving the information from the internet. And now if you say it's like, hey, send an email, then that is mean like acting on the environment by like sending out information. So like AI agents, it basically like it's defined first by the environment it's operating. So let's say like ChatGPT operates the internet, then it's like the environment is the internet. If you have an agent in Gmail, then Gmail is that environment. If you have a coding assistant agent, then the maybe like whatever the coding editors that you use, like VS Code or whatever, or like Terminal, is the environment. Or like so like it's characterized by the environment it operates in, and then like given it users task, this agent leverage a tools like leverage the tools it has access to perform the task. And how does it do it? It will need some kind of like a brain that determine like, hey, what task is this? What tool should I use? How do I evoke the executions? And how do you determine that this task has been accomplished? So in terms of the AI powered agent, that brain is an LM. like is a model. So we have like GPT-4 power agents or like Claude powered agent. So it's really, so like if you think about like AI power agents, you basically think about like, hey, what are the tools that it has access to? And second, like how good is its planning capability? Because as an aspect like the environment is pretty much defined by the agent developer, and the user and the task is supplemented by the user.
And then there's a central concept to agent, which is planning. How do you
Yeah.
think about it, and what is specific about planning from a model perspective?
Planning is very, very, very hard. Yeah, so I think it's like we basically, so we talk about like agent has like two big components that we like a lot of this like we need to work on is like the tool use, right? And a different set of tools the agent has access to, and the planning like how to use this set of tools efficiently to solve the given task. So tool use actually, like in the early days we already have the function calling. So tool use, what is the tool use? Like you evoke a tool maybe by calling a function, supplementing the parameters to like do the function, right? So function calling, like we pretty much like understand a lot more about it. But planning, like how to use those tools effectively, like how to come up with like a roadmap, an outline of plan to like solve the task is like really, really hard. So like even like something very simple can require a lot of like reasoning steps and like a sequence of actions. So 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 planning is also not a new problem. Maybe what is new is that using LM to solve planning, but planning itself is not new. So planning at its core, you can think of it as like a search problem. So what that means is just like here, given a task, like hey, it's like you have a goal over there. Like there are many different paths toward that goal. Maybe like you need to turn left first, turn right first. All right, like there are many different ways. So like planning is basically you search through like the entire possible like paths and choose the one that is most that's the best path. Or if there's no path, you need to determine that there's no path, there's no possible way to solve this task. So planning is a search problem. And I think in many AI textbooks, even the books I mentioned from Peter Novick and Russell, they have like a huge section on planning. So the challenging with for LM for planning is that I feel like it can pretty go into like multiple minutes here. But I think this is like I do think this like planning is you need to be able to like understand not just like generate a sequence, like not just like knowing, not just like saying what you do next, but you should be able to like predict what could be the outcome of that. Does it make sense? Like for me, it's really hard for me to decide should do A or B if I don't know what is the output of that. What's the expected outcome? So I do think it's like there are certain techniques that make LM better at planning. So like for example, like when like not just like before it's trying to like do an action, try to like predict like if I do that action what would happen. Like if I want to, like if you turn left and turn left is a cliff, you probably don't want to do it, right? Planning is incredibly hard. And I do think, say, I think in my book I have a very long sections on planning. Actually made it public on my website on the session on planning. So if what I'm saying is like a little bit too abstract, go read the blog post. It's free and it's online. So basically the idea is just like, can LM plan? Like, is there any fundamental reason why LM's gonna plan? Because we have people like on the one side of the spectrum, like Yang Lekun from Meta, who's incredible scientist. But he also said that's like LMs, like auto-regressive LMs just cannot plan. But and they kind of disagree. I think just like maybe like we just don't give LLMs enough like tools to be able to plan effectively, or maybe like we just don't have the models good enough. Maybe like stronger models can become like better at planning. So I think like that section discuss that, and so discuss like different tips like how to get the model to plan more effectively. So for example, like to plan well, you need to understand the set of tools you have access to pretty well. So it needs, so like if the tools are too confusing to use, that actually very hard for the model to go to like plan, right? So you need to look at the tool set the model have. Maybe you need to like change the name to make it more understandable, write better documentations, or maybe like break the tool into like more simpler tasks. One thing I want to say about planning is like actually quite not obvious, and I find it quite fascinating. It's like actually hard for us to like create data to train models to become better planning. And the reason is that like when we ask humans to generate like what they consider the best plan for an actions for a task, it's actually like not quite the best plan for AI. Because what is easy or efficient for humans is not the same as easy and efficient for AI, right? So for example, like um, if browsing is like a thousand websites and summarize 1,000 websites would be really boring and slow and tedious for humans. And as a humans, I probably could not do it. Actually, I did it for my like I tracked like 1,000 repos, so I did it one point. But like it's like a very tedious and painful task. But for AI, it's actually really easy, right? You can just like browse 1,000 websites and like generate summary at the same time. So one challenge to like generate data to train the model to become better planning is that we can't quite rely on human laborers, annotators to do so. So a lot. So like there's a whole school of like how do we come up? How do we know like generate like good plans for AI to learn from, so you can learn it better at planning.
All right, so it's been wonderful. There's more chapters, more topics. We could talk about data set engineering. Could talk about inference optimization and all the things. But hopefully that gave listeners a good flavor for what you discuss in this book, which again, is amazing, and I very much truly enjoyed and fully recommend to anyone interested in the topic of AI in general and AI engineering in particular. So the book, which is both in electronic format and is starting to ship in physical copy. My physical copy is going to arrive soon, I'm told. There is a GitHub repo which is associated with the book as well. Is that right?
Yeah. So I think like in the process of writing the book, I went through like so many resources. I think the book itself like referenced like over 1,000 links, and I myself personally went through like a lot more links. So I found like a lot of it was very helpful. So like the GitHub repos has about like 100 like of the resources I found like the most helpful in the process of writing the book, so that like if you just go through the resources directly, I think there are a lot of great learnings there from everyone. And so there's a repo also has just like table of contents and like summaries for each chapter, and some prompt examples, and stuff like that. Yeah, so it's this is not a tutorial book, so there are no coding examples. It's pretty. I hope it's a good thing, because I felt like all the frameworks today change so fast. So I feel like any coding example using any of them is gonna go like outdated like pretty quickly.
Wonderful. Thank you so much. I think this book is going to be a major hit. Really appreciate your coming on the pod and telling us all about it and sharing some of the key insights. It's really appreciated. Really enjoyed it. Thank you so much.
Thank you.
Hi, it's Matt Turck again. Thanks for listening to this episode of the Mad Podcast. If you enjoyed it, we'd be very grateful if you would consider subscribing if you haven't already, or leaving a positive review or comment on whichever platform you're watching this or listening to this episode from. This really helps us build the podcast and get great guests. Thanks, and see you at the next episode.